10 chemistry. We will start with the electrolysis of acidulated water, then move on to the electrolysis of CuSO4 with the help of platinum or graphite electrode, and then move on to the again electrolysis of copper sulfate with the help of copper anode. So these are the three electrolysis process we will discuss about in this class. So let's start with the acidulated water.
So now if the question is that why a small amount of acid alkali salt is added to water before it is electrolyzed. Pure water is a very poor conductor of electricity, you all know, because since it uses it to a small extent because of its very low degree of dissociation. In presence of a small amount of acid, alkali or water soluble salt, the degree of dissociation of water increases and it can act as a electrolyte. For example, if a traces amount of dilute sulfuric acid is added to pure water, H2SO4 itself ionized to produce H plus and SO4 minus 2 ion, and helps to ionize water to form H plus and OH minus ion. Due to the presence of these ion, water act as an electrolyte. So consequently, water get converted into a better conductor of electricity. So now move on to the another topic, that is called the electrolysis of acidified or acidulated water with suitable reaction. Actually, if we see that electrolysis of acidified or acidulated water is represented by the adjacent this diagram also you will see in screen. The electrolyte is water acidified with the dilute sulfuric acid. Electrode platinum foil used as a both cathode and anode. Temperature, it is carried out at room temperature. Ion present, if we see electrolysis solution, H2O breaks into H plus and OH minus, and H2SO4 breaks into 2H plus SO4 minus 2. Reaction occurring at cathode, if we see that 4H plus plus 4E, that change into 4H, and 4H change into 2H2. Now move on to the hydrogen gas evolves at cathode. In case of reaction of anode, that is OH minus, that is it release one electron to OH, then 4H OH to form 2H2O plus O2. Oxygen gas evolved at anode. Overall result, if we see that 2H2O, that is a change into 2H2 plus at cathode, and O2 at anode. The volume of H2 gas liberated at the cathode is twice the volume of oxygen gas liberated at the anode in this process. Now move on to the another question. If we see that electrolysis of aqueous copper sulfate solution with copper, if we see that starts with the copper sulfate solution, that electrolysis of aqueous copper sulfate solution, if we see that electrode will be cathode and anode both in platinum electrode. The electrolysis can also be carried out using graphite in both cathode and anode, or using platinum in one electrode and carbon or graphite in another electrode. Temperature will be at room temperature. Ion will be present as CuSO4, change into Cu plus 2 and SO4 minus 2. H2 also change into H plus, OH minus. Reaction occurring at electrode cathode, that is Cu plus 2. It will take 2 electron to change into Cu element, and both Cu plus 2 and H plus ion move toward the cathode, but as an electrochemical series, position of Cu plus 2 ion is lower than the H plus ion. So Cu plus 2 ion is reduced more readily than H plus ion, and reddish brown copper deposit at the cathode. In case of anode, OH minus, that is release one electron, and OH, then OH change into 2H2O plus O2. Both OH and SO4 minus 2 ion move towards the anode. However, OH minus ion is oxidized more easily than SO4 minus 2 ion to form O2, which is liberated at anode. So if we see that O2 gas is evolved at the anode, intensity of blue color of copper sulfate solution decreases due to the decrease in concentration of Cu plus 2 ion in the solution. Now move on to the another topic, that is actually called the electrolysis of aqueous copper sulfate solution using copper anode. That is electrolyte will be aqueous solution of copper sulfate, electrode will be copper, platinum or graphite is used as cathode, copper is used as anode. Temperature, if we see that electrolysis always carried out in room temperature, and this CuSO4 change into Cu plus 2, SO4 minus 2, H2O also change into H plus, OH minus. Reaction at cathode, if we see Cu plus 2 plus 2E, then Cu. In electrochemical series, Cu plus 2 ion is lower position than that of H plus ion. So although Cu plus 2 and H plus ion both move towards the cathode, Cu plus 2 ion is more easily reduced than H plus ion, and reddish brown Cu deposit at the cathode. So in case of anode, this Cu change into Cu plus 2 plus 2e, both OH and SO4 minus move toward the copper anode. On the other hand, copper anode is oxidized to form Cu plus 2, which occurs more readily than that of oxidation of OH minus or SO4 minus 2 ion at anode. So if we see overall reaction, reddish brown copper metal deposit at the cathode, whereas active copper anode itself ionizes to produce Cu plus 2 ion in the solution. So concentration of Cu plus 2 ion in electrolytic solution remain unchanged, color of solution remain unaltered after electrolysis. So today up to that, next we will start with another